questions 21 through 25 on the 2004 Grade 10 Cayley Math Contest. In a pack of construction paper, the number of blue and red sheets are originally in the ratio 2:7. Each day, Laura uses 1 blue sheet and 3 red sheets. One day, she uses 3 red sheets and the last blue sheet, leaving her with 15 red sheets. How many sheets of construction paper were in the pack originally? So I'll let the number of blue sheets be B and the number of red sheets be R originally. And they want you to find B plus R. Okay? They give you a little bit of a clue. They tell you that B over R is equal to 2/7. That's the little clue they give you. All right, so now let's work with this here. We've got 7B is equal to 2R. And let's see later on if we need to use that in any way. So initially we've got a certain number of blue sheets represented by B and a certain number of red sheets represented by R. And then we've got the first day, the second day, third day, and then at the end we get to the last day, which I'll call N. I don't know how many days there are. And then every day she uses 1 blue sheet. So every day you're going to subtract 1. Correct? All the way down to the nth final day. And similarly, every day she uses 3 red sheets. So you're going to take away 3 from the pack for red all the way down to the last day, which of course you would take away 3 as well. And then the good news is that when you get to N, the last day, there's no more blue sheets. Why? Because the last blue sheet has been used. So we're down to 0. But for red, you have 15 remaining. Okay? So I hope you understand that. Now, we take both of these scenarios and make equations. So from the first one, you can get the following equation, that B, every day you are subtracting 1 and there's N days, so B minus N is equal to 0. Okay? And then very similarly, for the second one, it would be R minus 3N is equal to 15. So those are our 2 equations. Now you say, well, I've got B, N, R, I've got 3 variables, I've got 2 equations. Is there any way I can narrow it down to 2 variables? And the answer is definitely, because they gave you that clue. They told you that 7B is equal to 2R, right? So that means that you can isolate for one of these. Either one, it doesn't really matter. It's up to you. I'll just isolate for B. Why not, right? So B becomes 2R over 7. All right? So this equation, therefore, becomes 2R over 7 minus N is equal to 0. So there you go. I've got 2 equations now with just 2 variables, and I can solve. So here we go. We've got 2R over 7 minus N is equal to 0. And I've got R minus 3N is equal to 15. So the first one just gives me 2R over 7 is equal to N. And I think that's good enough. I can just substitute that into here now. So R minus 3N, and N is 2R over 7 is equal to 15. And therefore this looks like 6R over 7 is equal to 15. Multiply everything by 7, get rid of that fraction, 7R minus 6R, and then 7 times 15, which is 105. 7R minus 6R is just R, and therefore R is 105. All right, great. And then I need B, right? So B is 2R over 7, okay? B is equal to 2R over 7. R is 105 over 7. So that's what? 210 divided by 7, which is 30. All right, So the number of red sheets, 105, number of blue sheets, 30. So R plus B is 105 plus 30, which is 135. So 135 is the number of construction paper sheets in the pack originally. And therefore, number 21, the answer is C. In the diagram, A, B, C, D, E, F, G is a room having square corners with EF equal to 20, AB equal to 10, and AG equal to GF. The total area of the room is 280 meters squared. A wall is built from A to D, creating two rooms of equal area. What is the distance in meters from C to D? So a lot of clues here. So what we need to do is first partition this into different sections. And then once we do, we'll work with the clues that they give us. And I think doing this is sufficient. Those are yeah, that's good enough. All right, now let's start labeling this. A lot of this has already been labeled for us, but some of the sides have not been labeled, and I need to introduce some variables. So the first variable is this guy right here from F to G. Now they tell us that with these symbols and also in the question that FG is the same as AG. So if that's X, this has got to be X as well. And then let's see here. If this whole thing is 20 and from here to here is X, then this is also X, and therefore from here to here is 20 minus X. Correct? And therefore this is 20 minus X, and this is 20 minus X. All right. And then I think anything else that I need to label, well, from here to here is X, right? It's the same as that guy. So I'm going to label from here to here Y. And therefore here is X minus Y. And I think that should be it in order to get the answer. Okay, first let's work with the fact that the total area is 280. So how do I get the total area? Well, 280 is the total area, right? And that is equal to what? Just using our variables, let's see here. This whole thing is 20, right? And this is X. So that rectangle is basically an area of 20 times X. Correct? And then I have to add this shape or rectangle most likely. And that looks like the dimensions are 10 and 20 minus X. All right, so here we go. Let's just do the algebra there. 280 is equal to 20x plus 200 minus 10x, like that. And this is 10x. And then put the 200 on the other side and you get 80, and therefore x is equal to 8. All right, that's very helpful. Now we get to this part, the wall that they are building from A to D. So they've drawn it in there. And they're saying that when you do that, it splits the entire room into two rooms of equal area. So that basically means that this shape right there is the same in terms of the area of this shape. Okay? So that is what we have to figure out next in terms of an equation. So the two areas are equal. So what is the first area? First area, let's see here. We got that shape, which is x times x. Okay? So x squared. And then I'm going to add this little box right there. And that looks like 20 minus x and x minus y. And then I have to add this triangle here. And that is 1/2 base times height. The base is 20 minus x, and the height is y. Okay, no mistakes, hopefully. And that is equal to the area of the other shape that's been created by the division with AD. That looks like this triangle in here, which is 1/2 base times height. So the base is 20 minus x, and the height is y, plus this shape right here. And that is 10 times 20 minus x. Okay, so that's our equation. And let's work with that. The good news is we know x. So let's start with that equation, substituting for x equal 8. So we got 8 squared plus 20 minus 8 times 8 minus y plus 1/2 20 minus 8 y, and that is equal to 1/2 20 minus 8 times y plus 10 times 20 minus 8. And let's see what this gives us. So we got 64, and then we got 12. 12 times 8 is 96, and then 12 times negative y is minus 12y. And then we've got 20 minus 8, which is 12. 12 divided by 2 is 6y. And then that gives me 12 divided by 2 is 6y again. Plus 20 minus 8 is 12, plus 120. All right. 6y's go. 64 plus 96 is 160. Bring the 120 over, and then bring the 12y over. This looks like 40 is equal to 12y, and therefore y is equal to 40 over 12. And in lowest terms, that is what? 10 over 3. Okay, great. Let's go back and remind ourselves what it is that they want. They want the distance from C to D. So C to D, that whole thing. Well, C until this point is 10. So C to D, you just have to add the y. Okay? So C to D is going to be 10 plus y. So CD is equal to 10 plus y. 10 plus 10 over 3. Common denominator, and we get 30 plus 10, 40 over 3. 40 over 3 is choice E for number 22. A soccer ball rolls at 4 meters per second toward Marcos in a direct line from Michael. The ball is 15 meters ahead of Michael, who is chasing it at 9 meters per second. Marcos is 30 meters away from the ball and is running toward it at 8 meters per second. The distance between Michael and Marcos when the ball is touched for the first time by one of them is closest to. Oh, they don't tell you who it is, so we have to figure out who it is. So first, let's just draw the original diagram, and let's start understanding it. So we've got Michael here. I'll just write MI for Michael, and then Marcos is over here. I'll write MA for Marcos. And then originally the ball is somewhere here. So we'll write B for ball. And we're told that the ball is 15 meters ahead of Michael. So this is 15. And we are also told the speeds. The ball is 4 meters per second going that way. Michael is 9 meters per second going that way. And Marcos is going this way at 30 meters away. So this is 30. And his speed is 8 meters per second. So that is basically the original diagram. Now, let's figure out the final diagram, which would be the exact same in terms of the distances. I don't want to change that. But of course, the positions of Michael, Marcos, and the ball are not the same. The ball is going to be somewhere, I really don't know, but let's just say it's going to be somewhere here. It's going to travel, right, obviously. So I'll just put it here. Now I'm going to retain this position right here, and therefore that distance I'm going to keep as 15. I don't want to change that. But since the ball went from here to here, and I don't know how far the ball went, I'm going to label that as x. The ball travels a certain distance. And in a very similar way, Michael travels a certain distance, but we don't know where Michael ends up, right? That's the challenging part of this question. He's going to be somewhere in this region. He might get to the ball and therefore be the first one to touch the ball, or he may not be the first one to touch the ball. He might be, I don't know, he might get to here. So we'll just leave that little region there. In a very similar way, Marcos is going to go this way, and we also don't know. Where does he end up? So somewhere is Michael and somewhere is Marcos. Okay? So that is sort of the dilemma here. All right, no problem. We have everything we need to solve for this question, and let's go for this. Now, there's an equation, as I'm sure you know, that speed is equal to distance over time, correct? Now, in this case, we're going to revert this or change this slightly and get time is equal to distance over speed. That's perfectly allowed to do that. And we've got Michael, we've got the ball, and we've got Marcos. Okay? And in our first scenario, we have to basically figure out who touches the ball first. I don't know. I wish they told us, but they didn't. So let's say Michael touches the ball first. All right, let's say that is the scenario that happens. We don't know, but we can figure it out. Now, if that is true, then that means that the amount of time that it took the ball to go from here to here is the exact same amount of time that it takes Michael to go from here to there. All right, that's the only way he can touch the ball first. So for each of these, we've got to figure out the time. The time is right here. It's d over s. So it'll be d over s. I'll just write 1 to denote it's for Michael. For the ball, it's d over s, but I'll write 2. And for Marcos, it's d over s, but I'll write 3, just to show that these are different variables. All right. So for Michael, what's the distance? If he touches first, if he gets all the way to the ball, well, his distance will be 15 plus x, correct? So 15 plus x. What's his speed? They tell you the speed is 9 meters per second. All right. Now the ball is going from there to there. So the ball travels x. And the speed of the ball is 4 meters per second. Marcos, we have created a situation where Marcos does not get to the ball first. So he's somewhere in here. He gets to this point. We don't know. So we don't know where he is. So we have no idea yet what is his distance. So I'm going to leave that blank for now. But since these two times are the same, these are equal. All right, so we can easily solve for x. Cross multiply and you get 60 plus 4x is equal to 9x. And therefore 60 is equal to 5x. And therefore x is equal to 12. Okay, so x is equal to 12. Now let's figure out the time. The time that it takes, t, is equal to d1 over s1, right? It's right from up here. And d1, we know x is 12, so d1 is 15 plus 12, which is 27. And the speed for Michael is 9. So that's 3 seconds. So that means in 3 seconds, Michael was able to get to the ball. All right, that's very helpful because now we can turn our attention to Marcos. Marcos, his time is d3 over s3. Now 3 seconds has gone by in this scenario, so we can put 3 here. And then we can use his speed, if you remember was 8 meters per second, to figure out how much he traveled, his distance. And therefore d3 is 24. Now let's go back and see if 24 makes sense. X we figured out was 12, right? Okay, x is 12. Now, this distance from here to here originally was 30, correct? So that means from here to here was 30. If this is 12, then that means that this distance is 18. So when the ball gets to here, it's 18 from where Marcos originally started. But we're saying that Marcos traveled 24. If he traveled 24, he's going to be over here somewhere. And that means that he actually has already touched the ball. So that means that Michael does not touch the ball first. All right? So I really wanted to do that carefully and illustrate. Now, on an exam or on a math contest, you might have done the other scenario first, that Marcos touches the first. And if you did, you get the answer quicker. So it's sort of a toss-up, 50-50. I did it in the way where Michael touches first. At least that's what I thought. Or even if I didn't think that, I did the question in that way. All right, no problem. One thing we know for sure, that Marcos touches the ball first. Okay, so let's go back and do the exact same thing, but this time knowing that Marcos touches the ball first. So here we go. This time instead of Michael, I put Marcos right there. And the exact same scenario, but this time, because Marcos touches first, the ball's time and Marcos's time will be equal. All right, let's figure this out with our diagram. Let's erase the fact that it's 12. And here we go. So now we've got d2 over s2. d2, of course, is x. And the speed for the ball is 4. d3, Marcos was originally here, correct? And he's going to be the first one to touch the ball. So what is this distance? Well, remember, this whole distance was 30, remember? So if that's x, this has got to be 30 minus x. So 30 minus x, like that. Okay? So we can substitute that in here. 30 minus x. And his speed is 8. Okay, so now let's just do the cross multiplication. 8x is equal to 120 minus 4x, and therefore 12x is equal to 120, and x is equal to 10. Now we have to just figure out the time for everybody, and we can easily do that. Let's just do it with the ball. d2 is 10. The time is 4. So this looks like 2.5 seconds. Okay? That's how much time elapses for the ball and Marcos to meet. Now we just have to figure out how far does Michael go in 2.5 seconds. All right? So we want to figure out a distance, correct? So using this formula, we would use distance is equal to speed times time. So distance, his speed is 9. Yeah, 9. So 9, and the time is 2.5 seconds. And therefore this is equal to 22.5. All right, we got it. So let's go back and fill all this in. Michael was originally here, correct? He travels 22.5, so he goes all the way here to 22.5. This is 22.5. And we have to figure out the distance between Michael and Marcos. So Michael ends up here. Marcos ends up right here, because that is where the ball is. He touches the ball first. So now we just have to figure out this little guy, that distance right there. Well, we know that x is equal to 10, right? That's what we calculated down here. So this 30 minus x is really 30 minus 10, which is 20. So this is 20 right here. And then this whole distance, all the way from there to there, from the original scenario, was 15 and 30, which is 45. So 45 minus 22.5 minus 20. And that gives you 2.5. So this little distance in there, which is the distance between Michael and Marcos, is 2.5. And that is what they wanted you to figure out in the question. So number 23, the answer is C. 4 identical isosceles triangles are arranged as shown with points A, B, C, D lying on the same straight line. A new triangle is formed with sides the same length as AX, AY, and AZ. If AZ is equal to AE, the largest integer value of X, such that the area of this new triangle is less than 2004 is. The first thing I want to do is draw in these 3 lengths. So AX is from here to here, AY is from here to here, and AZ is from A, obviously, to Z, like that. And then I will draw right triangles. So I want to draw the bases, like that, all the way down. And these can be representing the base, or you can represent them as the height. It doesn't really matter. It just helps us figure out a lot of equations that we will need. Now I'm going to label them. The lines that I just drew, top to bottom, I will label those H, like that. And then these are right triangles, and therefore we can get Pythagorean relationships for each of these. So for AX squared, I get from here to here, which is 1.5x, so 3 over 2x squared, plus h squared. And then for AY, in a very similar way, I get from here to here, which is 2.5x, so that's 5 over 2x squared, plus h squared. And finally, AZ squared is all the way from there to there, which is 3.5x, 7 over 2x, plus h squared, like that. Okay? So that's the first part of the setup of this question. The next part is a clue that they give that's very important, very helpful, and that is AZ is equal to AE. Now AZ we've already calculated, but be careful. We calculated AZ squared, not AZ. So don't make that mistake, because you'll never get the right answer if you do. So AZ is equal to AE, and since I've got AZ squared, I'll just square both sides. It just makes it a little bit easier for me, like that. Now AZ we have right there, so I'll put that in here. 7 over 2x squared plus h squared. AE, what is AE? Well, it's all the way from A till E, and we know that's 4x, right? 4 of these guys. So that's very, very nice that it works out like that. So AE is 4x, and don't forget to square this. I think, the challenging part of this question, in my opinion, is these small algebraic errors that can be made. So now this helps me tremendously because I can isolate for h squared. I got 16x squared minus 49x squared over 2. And let's see what this gets. Oh, over 4. You see what I mean? I just said it, and then literally 10 seconds later, I made the same thing. So don't make those small algebraic mistakes, because you know how to do the question, but you make those small mistakes and you get the wrong answer, or you don't get an answer that makes any sense, and that's really painful. So you just add this fraction here, and you get 64x squared minus 49x squared over 4. And this is, let's see here, 15x squared over 4. And that is h squared. All right? And therefore, we can now plug that back into each of these and get a value for each of those in terms of x only. So let's start with ax squared. Ax all squared, therefore, will be 3 over 2x all squared plus h squared, which is 15x squared over 4. And this looks like 9x squared over 4 plus 15x squared over 4. And this is 24x squared over 4, which is 6x squared. And that's ax all squared, so therefore ax is root 6x. Correct? All right, let's do the same thing for ay this time. Ay all squared is 5 over 2x all squared, so that's 25x squared over 4, plus h squared, which is 15x squared over 4. This looks like 25 plus 15 is 40. 40x squared over 4, and that is 10x squared. And therefore ay, we have to take the square root, don't forget that, root 10x. So we got ay, we got ax. Now we need az, but az is equal to ae, so we don't need to do this algebra. az is just ae, and ae is 4x. So az is 4x. And there you go. There you've got the three sides. Now at this point, you think, well, okay, I've got three sides of a triangle. How do I figure out the area? I mean, do I use herons? Some of you may not even be familiar with herons. And herons is a really cool, where if you got three sides of a triangle, and those sides are, say, A, B, C, and you don't know any of the angles, you can still figure out the area. First thing that you do is you find the perimeter, which is, of course, A plus B plus C. And then the area is the perimeter over 2 times the perimeter over 2 minus A times the perimeter over 2 minus B times the perimeter over 2 minus C, like that, all under the square root sign. And this will give you the correct answer. But as I'm staring at this, I got a little bit of a inspiration that I think these form a right triangle, which is very nice of them to do that. I believe so, because if you do ax squared plus ay squared, I think it equals az squared. Let's see here. Ax squared would be 6x squared, ay is 10x squared, and az is 16x squared. Yeah, it does. There you go. So this is a right triangle. Very nice. So that means you don't need herons. Well, doesn't break my heart, that's for sure. All right, so that means that this is a right triangle. And let's just label this. So this is a right angle right here. And this has got to be AZ. And this is AX. And this is AY. So this is what? Root 6x, root 10x, and 4x. Okay. All right. We got it. So we can figure out the area using just the standard 1/2 base times height. 1/2 base, so root 10x times height, which is root 6x. Okay, great. So what does that give me? Root 60 over 2x squared. And let's just go back to the question, remind ourselves what it is that they want. The largest integer value of x such that the area of this new triangle is less than 2004. Okay. So they want this area, root 60 over 2x squared, to be less than 2004, and they want you to solve for x, but they want an integer value for x. Okay, no problem. So that means x squared 2004 times 2 all over root 60, correct? And then let's just get the numerical value of this. And this is 517.4. And therefore, if I take the square root, it'll be 22.74. And they want the largest value of x to make this true. That is an integer. Well, that would be x equal to 22. Correct? So let's see here. The largest integer value of x such that the area of this new triangle is less than 2004. Yeah, 24, the answer is E. Excellent question. The number of positive integers x with x less than or equal to 60 such that each of the rational expressions 7x plus 1 over 2, 7x plus 2 over 3, 7x plus 3 over 4, all the way up till 7x plus 300 over 301, is in lowest terms, i.e., in each expression, the numerator and denominator have no common factors, is. So 7x plus 1 over 2, 7x plus 2 over 3, 7x plus 3 over 4, and so on, all the way up in that same pattern till the final one, which is 7x plus 300 over 301. They say to you that get all the positive integers from obviously 1 until 60 inclusive. And how many of those, there's obviously 60 of them, if you plug them into these fractions, will give every single term in lowest terms. Does that make sense? All right. Okay, so where do we begin here? Do we just start plugging in 1, then 2, then 3, and do it? Well, obviously, that's going to take about an entire weekend, and you've got about 6 minutes to do this on a math contest, maximum 6 minutes. All right, so the first thing is I have to get a comparison. I've got to make everything equal to compare it. Otherwise, it's going to take way too much time. And I can do that by concentrating on the numerators. The denominators, obviously, I can't make equal because they're different numbers. So the first one, for example, if I write it like this, 2 plus 7x minus 1 over 2, that has the same numerical value, right? I just wrote it in a different way. I haven't changed anything. I'm not allowed to change the value of it, but I can switch it around like that. If you do this, it becomes 2 over 2 plus 7x minus 1 over 2, which is just 1 plus 7x minus 1 over 2. Okay? In a very similar way for the next term, I can write it as 3 plus 7x minus 1. I haven't changed the value at all. And this then becomes 3 over 3 plus 7x minus 1 over 3, which is 1 plus 7x minus 1 over 3. In a very similar way, for the next one, 4 plus 7x minus 1 over 4, and this becomes 4 over 4 plus 7x minus 1 over 4, which is 1 plus 7x minus 1 over 4. So you get the idea. And we'll do it for the last one. And for the last one, I believe it will be 301 plus 7x minus 1 over 301. And that gives me 301 over 301 plus 7x minus 1 over 301. And this is 1 plus 7x minus 1 over 301. All right? So you notice how I got all the numerators the same by doing a little bit of manipulation. Now that means that if each of these numerators combined with those denominators are in lowest terms, then the original guys will be in lowest terms, because you're just going to add 1 to it. So this question is basically like asking, how do I get each of these guys in lowest terms? All of these guys. 7x minus 1 over 2, over 3, over 4, over 5, and so on. Okay? So that's what we're going to concentrate on. We're going to try to get each of these terms in lowest terms. And remember, our x is anywhere between 1 and 60, and they have to be integers. Now, when x is 1, if you substitute that into any of these, let's just say 7x minus 1, when x is, say, 1. So x equals 1. The value of 7x minus 1 will be 6, right? So eventually one of these guys will be a 6 over 6. For example, one of these terms is 7x minus 1 over 6, correct? This is 7x minus 1 over 2. This is 7x minus 1 over 3, 7x minus 1 over 4. Eventually you get 7x minus 1 over 6, right? And when this becomes 6, this will become 6 over 6. Is that in lowest terms? No, it's not. That's not in lowest terms because both top and bottom can be divisible by 6. When eventually it just gives a 1. So 1 is out. 1 as a possibility for x in this range is out. And 2, in a very similar way, you'll see very quickly, it will give for 7x minus 1, the value for 7x minus 1 will be 13. And therefore, eventually one of those terms, which is 7x minus 1 over 13, becomes 13 over 13. Again, that's not in lowest terms. So 2 is out. And in a very similar way, you'll see that that holds true for everything up until 43. Because when you get to 43, 7x minus 1 becomes 300. And since these terms go all the way to 301, one of these is 7x minus 1 over 300, and that basically would become a term of the form 300 over 300, which again is not in lowest terms. So all the numbers in this range from 1 to 43 would not give every term in lowest terms. So now we have to concentrate on terms for x between 44 and 60. So the first 43 have been eliminated. All right? Concentrating on these terms. Now let's try, all right? We don't know. It's like a big trial and error, right? But there is what of a system here. Now let's try what happens when you put in a number like odd and even, because I don't want to write them all out and go through every single one. That's going to take forever. But if I can separate them into odd and even, at least that separates them 50-50. If you have an even number, first of all, like 44, what do I get for 7x minus 1 over 3 over, well, we don't know the denominator yet, right? 7x minus 1 when x is 44 is 307. Okay? Any problems there? No, because we never get to a denominator to 307. So I don't see any problems there, and 307 is a prime number. So 307 is always going to be in lowest terms because there's no factor other than 1 and itself and we don't have a 1 here. It starts with 2. See what I mean? So 307 is fine. So 44, it seems okay. But what about 45? When I get to 45, 45 times 7 minus 1 is 314. And 314 is an even number. And therefore, it's going to be able to be divisible by 2. So like 314 over 2 is not in lowest terms. So then similarly, any time that x is an odd number, we are going to run into that problem, that we're going to end up with an even number for 7x minus 1, and an even number will always be able to be divisible by 2. So anytime x is odd, 7x minus 1 will be even and therefore divisible by 2. So we are therefore left with only the numbers that are between 44 and 60 that are even. So that it's 44, 46, 48. Not too many of them. That's good news. 52, 54, 56, 58, and 60. And we can go through these without too much pain. And we want to figure out 7x minus 1 for each of these. And let's see what we get. When it's 44, I actually did that. It's 307. And that's a prime number. So that's not going to give us any problems. This is one value of x that works. It gives every single expression in lowest terms. How about 46? 7x minus 1 will be 321. But that's a problem because that's divisible by 3. So 321 divided by 3, this guy right here, that's not going to be in lowest terms, unfortunately. All right, we eliminated that guy. How about 48? That's 335 for 7x minus 1. That's divisible by 5. So remember, when that expression comes, it's not in lowest terms. 349 is what you get for 7x minus 1 when x is 50. And that's a prime number. So there you go. We got another one that meets the criteria. When x is 52, we get 363 for 7x minus 1. That's divisible by 3. So this term will be not in lowest terms. 54, it's 377. That's divisible by 13. So this term will be not in lowest terms. 56 is 391 for 7x minus 1, and that's divisible by 17. So this term will not be in lowest terms. And 58 is 405, which is divisible by 3. It's also divisible by 5. So either one. So that's not going to be in lowest term. And finally, 60 gives you 419, and that is a prime number. So that one will work. That will be in lowest terms for all of our expressions. So there you go. We got 44, 50, and 60 as values of x that will make every single one of these expressions in lowest terms. And if it does, then every single one of the original expressions will also be in lowest terms. So the number of values we got was 3, and therefore number 25, the answer is C.